Hi guys, let's take a look at this question where we have a 2 kg block that is released from rest, so initial velocity will be 0, at point P, 5 meters above the ground. It slides down a smooth, frictionless curved track PQ, so PQ is friction is 0, and then you can see on the diagram QR, there's definitely friction there, and the length between the two is 10 meters, and then we have a little barrier there. 5.1, state the principle of conservation of mechanical energy in words. So the principle goes, the total mechanical energy in an isolated system remains constant. Or you could say, the sum of the kinetic and gravitational potential energies in an isolated system remains constant. Anything along those lines. 5.2, use the principle of conservation of mechanical energy to calculate the speed of the box when it reaches point Q. So when it reaches that point. Okay, so we can use our formula, mechanical energy at the top, mechanical energy at the bottom to get the V. Right, so I'm just going to write it down on this page. So we can top and bottom. So EP plus EK top is equal to EP plus EK bottom. All right, they are the same. So gravitational potential energy is mgh, and we know that kinetic energy is half mass velocity squared, and that is also going to be how it will look at the. All right, so the mass of the box is 2. We know G is a constant, 9.8, and the height is 5 meters. They have given it to us, 5 meters above the ground. We know that this is 2. What was the initial velocity at the top? It is released from a point of rest, so initial velocity is 0, or the velocity at the top is 0. So actually, this whole part here will be 0, but just jot it down just so you could see for yourself. Then same calculation is 2, 9.8, but remember now at the bottom, the height is 0, all right? So I would just write it down, but anything multiplied by 0 will be 0. And then again, we have mass of 2, and they want the velocity when it reaches point Q. So that is the unknown, the final velocity, right? So multiply that is 0. Anything multiplied by 0 is 0. So multiply that, well, not multiply that because that is also equal to 0. And then you do your math calculation, you divide, you get the square root, or the square root, and you get your speed to 9, then the box passed point Q and moves 10 meters on a rough horizontal surface before striking the barrier at point R at a speed of 4 meters per second. All right, so the final velocity is 4 meters per second. 5.3, use energy principles to calculate the magnitude of the average frictional force acting on the box as it moves from Q to R. All right, now, which formula could we find, or how do we find the friction, right? We can use this formula because then we have the net energy, right? And we also need the speed to be able to calculate the frictional force. All right, so let's start there. So I'm just going to jot down my equation and I'm going to expand it so I know what I have to put there, right? So what is going to be the net forces acting on my block when it comes here? It will be the normal force, it will be the frictional force, and will definitely be the weight. But what will be the horizontal forces? That will be the frictional force, right? Then we're going to have the change in kinetic energy. So it will be half mass velocity final minus initial. All right. So how do I expand that? Right here, guys, W will be frictional force, distance, cos of theta. And because it's the same block, we can just simplify this formula as well. And now we can start substituting. So this is what we want, right? We want the frictional force. We have the distance that it travels, it's 10 meters. and it's cos of 180 because it's the frictional force that we want. Then we know the mass of the block is 2, the final velocity they've given us to be 4, and we have just calculated the initial velocity because initial velocity will be at point Q, and the speed at point Q is this one here. So minus 9,90 squared, all of this will be. Then you do your math calculations and you find friction on its own to be 8,2. Then the barrier exerts an impulse of 14 newtons per second to the left on the box when the box strikes the barrier, 5.4. Calculate the change in kinetic energy of the box after striking the barrier. So we can take left as negative or left as positive. I take left as negative and right as positive. So I'll just tell the examiner that's what I'm doing. So I'm just going to erase what's on the slide so I can do 5.4. So in 5.4, right, they want the change in kinetic energy. So what do we need to get kinetic energy? We need velocity, we need mass, but we know we have mass already. So what do we need? We would need then the final velocity after it strikes the barrier, because remember we've just calculated, or they have given us the speed at this point. They've given us the velocity at point R, which is 4 meters per second. But when it reaches point R, it hits that box. So then point R becomes our initial velocity, and when it hits the box, it moves to the left, and somewhere here there will be our final velocity, right? So we can calculate that. That's what we need. So how do we calculate that? We can use this formula, because it is an impulse formula, because they've given us the impulse. So then it's going to be very easy. Our impulse have been given as 14 newtons per second, and we took left as negative, so it's going to be negative 14. Our mass is 2. Remember, I just said our final velocity is going to be the unknown 1. And our initial velocity will be at R, which we have been given as 4. And it is to the right, so it's positive. And we get our final velocity. We do our mathsy calculations, and we get 3 meters per second. All right. Then they want the change in kinetic energy. So now it becomes a little bit easier. We know that the change in kinetic energy will be half mass, final velocity minus initial velocity. Then I'll just substitute all my things here. We know we just have gotten the final velocity, so it's going to minus 3 squared minus 4 squared. So maybe just put that in a little bracket. And then we get negative 7 joules. And that is my change in kinetic energy. And that is it, guys. That would be the change in kinetic energy after striking the barrier. See ya.